Well, that's kind of fun. It's giving me messages. All right, there we go. All right, we are live on YouTube. I'll go to that view. Going to switch over to Lauren in a second, but Redwood Talks. Once a month, we're trying something new with the Redwood core team. We have a lot of internal experts on the core team across a variety of topics in full stack development. And then Redwood works with a lot of partners in the JavaScript and full stack ecosystem. And we wanted to just share information with each other and have monthly talks where there's a casual presentation. We'll do 2 of those today for about 20 minutes, and then we'll have some discussion with the core team. And there's 2 presentations today. So at the second half of the hour, we'll meet Jason from Relay, who's going to be talking about how you can do session replay inside of GitHub issues, and also show us what relay.io can do. That'll be fun. And then first off, we have Lauren from the Guild. That if you've ever used Redwood's API, you have the Guild to thank for how silky smooth that is, along with a lot of people who help implement some features. But Lauren, I'm going to hand it over to you. You're going to talk about GraphQL Fragments and further unlock the mysteries of GraphQL for us. So thank you in advance, and over to you.
Hey, thank you, David, and thank you for having me. Let me quickly share my screen, because today I will be sharing a bit of knowledge about GraphQL Fragments. Let me play that. Yeah, I prepared a small little presentation quickly today. So let's go through it. So first of all, what is a fragment? And those a bit familiar with GraphQL have probably seen it before. So a fragment is basically a type of GraphQL document that can be broken down into several pieces. First of all, we have the fragment keyword, the fragment name followed by the on keyword, and then a type condition, which specifies the type on which the fragment can be used. And then last, we also have the selection set, which is quite similar to actually a query or mutation operation selection set. And then how do you even use a fragment? Right, you can write your query operation and then write those fields inline, but you could also write those selections for those specific types as a fragment definition, and then instead spread the fragment within the selection set of the specific fields within your query operation. So in this case, it doesn't probably not make too much sense, but it's just for the sake of showing what the fragment is capable of doing. This gets more interesting when you actually want to reuse a selection set at different stages or at different levels within your selection set. Then moving shared fields to a fragment and spreading it on multiple selection sets could make the GraphQL operation a bit smaller. And then also there's a special type of fragment, which is called inline fragment. And there you don't even have to specify a fragment definition, but instead you can, on a field, specify inline fragment definition selection, specified by 3 dots followed by the on keyword and then the type condition, and then write those fields on there. Actually, also this operation does not make too much sense because the user field only is a user, so we'll always have a user type, so you don't need to specify the fragment here. But there are actually cases where you need to use a fragment. One of those is for union fields, and those of you who have used those before must have encountered this before. A union member is basically where a field can actually resolve to either one or the other type. And what you have to do is actually on that field specify inline fragments or normal fragments, because only the type name, which is a shared field between all GraphQL types, can be queried on the field itself. And for all other fields, you have to write those inline or normal fragments. Otherwise, you will get a validation error and your document will get rejected. And there's also another use case where you need to use fragments, and this is when you have an interface. So in this example, we have the node interface, which implements the ID field. And then we have a user and a boat, which also have additional fields alongside the ID field. And then if you want to query fields of a specific fields of a type that implements the interface, you also need to use those inline or normal fragments for querying those fields. Not using them would not allow the GraphQL engine to actually understand what kind of fields need to be resolved. And also, aside from that, it's not a necessity, but a common practice that evolved in client applications that have a normalized GraphQL cache is to actually use fragments for specifying data that is queried by a query operation, but then also later update by a mutation operation. So by sharing the fragment between both the query and mutation operation, you make sure that when you execute the mutation, all the relevant data that you're using in your application is refetched from the server after the mutation is completed. And the benefit of this is that the cache on your client is as up to date as possible. As everything else in GraphQL, the fragments are validated, and each fragment has a type condition. And if you try to apply a fragment on a field that does not have the type specified in the type condition, you will basically get a type validation error, and you won't be able to execute the GraphQL operation. At the same time, there's also recursion, which is not supported by GraphQL Fragments for the simple reason that you can actually cause an infinite loop by doing this. And because of that, the spec just says you can't reference a fragment within itself, which also sometimes is a bit weird because all of you probably know GraphQL. And within GraphQL, the data from GraphQL actually also comes from the introspection query, which is executed against your GraphQL server. And a field has a specific type, and the type on a field can be a list, and the list could be infinitely listed. Like you could have a list of lists of lists of lists of lists, but in the introspection query, you would have to specify all those selections. So you would need to build a tree for querying the actual type. So some people complained about this in the past, that their type is too deep for the introspection query. And the current recommendation for this is to just use your own introspection query instead of the default one that comes from GraphQL.js, which is a very funny fact in my opinion. Let's talk a bit about what's different between fragments and GraphQL operations. So if you have a simple GraphQL fragment, you cannot execute this against the GraphQL server. It will basically reject it and say could not find executable definition, whereas a single query operation can be executed. And then finally, if you mix the query operation with a fragment operation, it can actually be executed. And then there's another difference, which is fragments have no variable definitions. So on a query operation, you can define your parameters and then pass that to as arguments to specific fields. In this example, the ID and the avatar size. And an interesting thing is that in fragments, you don't have these. So the second example here is invalid, but there's also another quirk within GraphQL, or a loophole, I would say, that you can actually like pass through argument variables, but there's no clear data flow on how those are passed. So if you write the query operations, a document with a query operation and a fragment, you can actually within the fragment use the variables which are defined in the query variable definitions. And it's kind of weird in my opinion. So there's also a parameterized fragments RFC, and what this allows is actually making what I just showed easier, because it allows actually fragments to have variables, and then furthermore pass down the variables from a query operation via arguments to a fragment operation. And this makes fragments really reusable, in my opinion. For example, if this query here would power a user list or user profile, you could reuse the user fragments with different avatar sizes, one for the big avatar of the user, your profile you're watching, and then maybe you want a smaller avatar for the friend list. Yeah. Oh yeah, and also parameterized fragments could be supported by the GraphQL server, but actually because all the information for the fragments and query operations is already there at build time, tooling could take all these partials and fragments and queries and compile it into a single GraphQL operation. So the server does not necessarily need to support parameterized fragments, but only the build tooling needs to do it. And then there's Relay Compiler, which does this for years. Like all Facebook is built on those parameterized fragments. Which brings me to the next thing, fragment UI component development. And this is very interesting, and we wrote about it a lot and talked about it a lot over the last month. And the idea behind this is basically to have your component tree and split the data dependencies of each, or not split, but declare the data dependencies of each component within that component tree as a GraphQL fragment. And you have avatar, user list items, friend list, user profile header, or user profile. And within those fragments, you kind of compose up your big GraphQL operation. So let's dive a bit deeper into that. So the first step here would be to describe component data needs as fragments. So here we declare the avatar user fragment, which needs data from the user. And then we have our avatar component that actually needs the data that we just defined in the user fragment, and then just renders an image that is using data defined in the fragment. Next step is then to actually take the fragment and the UI component we just declared, and then reuse it in a new component that wraps the smaller UI component by first spreading the fragment into the data dependency or the new fragment of our bigger component, and then also declaring additional data that is needed in the current component. In this case, the full name. So what we're doing here is using the avatar component within our user list item and just pass down the data that is specified through the fragment we imported or spread here. And then also we use the data that we just declared at this level. And then we can do this up to the top level where we have our query operation. And there we spread all the high level query or UI elements within our application. So in the end, what we're doing is just executing one big GraphQL operation. And the benefit here is that if we previously declared everything into a single query operation, we would have this kind of HTTP request waterfall, because as a component is rendered, it fetches data, then it passes it down, then the next component fetches data, and so on. We now kind of avoid this problem by just having this one big query at the top level, executing this, and then we have all the data, and then we pass this down. Obviously, another solution here would be to not use fragments, and then instead write one big GraphQL operation, and then pass the data down. But then we lose this kind of like clear data flow and the explicitness that each component describes through a fragment what kind of data it needs to be rendered. Because then we actually have to manually write all those typings. So by following this pattern, we probably have a bit slower of a development workflow at the beginning. But then once we wrote this avatar component for the first time, we can reuse it in any context where we have access to a user object or something like this. And even then we could make it more generic. We could abstract something as an interface that implements an image URL. And then we could even use this avatar for non-user entities or something like that. Yeah, and this is then we will basically end up with this component tree. Yeah, and also we already support this, and obviously a Relay compiler and Relay supports this since forever. We are just recently catching up. So with GraphQL CodeGen, we also now have a solution for this. We are still not 100% there because fragment arguments or parameterized fragments is still something we need to tackle, but it is definitely on our roadmap. Yeah, so this is basically my my small GraphQL fragment presentation. And if anyone has any questions or wants to start a conversation on anything around that, feel free to do it. Yeah,
Jump in, Danny.
Hey man, I see you're very pleased with that joke about that was a fragment about your fragments. That really pleased you. So this is super cool. I've actually never, people in the community talk about fragments, but I've never used it myself. So finally, I understand what it is. There in your code, you had use fragment in the middle. What was the purpose of that? Because if I understood correctly, you're making one query using fragments, which, yeah, that all makes sense. But what does the use fragment there do?
Oh, the use fragment is actually another concept that I did not mention on purpose, but we can go into it as well. So by default, if you generate TypeScript types from your GraphQL operations, you have your query operations, and then you basically have access to the whole query result in your TypeScript types. For example, in my top level component, where I use my where I have my use query call, I can access the result, the data result, and then access the fragment data from a component deep in the tree. So what's happening here is that we're kind of bypassing the data dependencies because we're accessing data of a component down in the tree, even though we're not specifying that we need the data here through a fragment. So what we did, and what Relay is also doing, is we kind of hacked around it by using TypeScript magic for hiding the data from where it is not required. So the use fragment call is basically an unmasking function that takes the result, which is TypeScript magic, and then based on the GraphQL fragment document string and the data dependency that we pass into it, it unmasks the data and then returns the data with the correct type so we can access it within that component. So the benefit here is that only the components that define via fragments a data dependency can actually access it. So this keeps the data flow clear and does not allow other components to accidentally access data they don't require or declare that they need it. Glad I satisfied you with my answer.
I had a question about, I always thought Relay had, like, they were more of a compiler, and that, like, basically before, is it the same for CodeGen, where, like, before you even, like, send code to the browser, all those fragments do disappear and just become the one query? Or is it like that the GraphQL server, when it sees the fragments sent, it will do it all at once? Or is it like, do they disappear by the time your code finishes the build step? Or is it
Oh,
the
so
GraphQL server? Yeah.
okay, so what happens in real compiler is that they are actually compiling anything like GraphQL operations and fragments into a single operation at build time. And with GraphQL code generator, what we're actually doing is only generating types, but we also have options for optimizing the queries, which is currently actually using an older version of Relay compiler internally. But since Relay compiler moved on to be written in Rust, and we kind of cannot reuse that functionality within CodeGen for compiling the queries, it's also on our roadmap to support this compiling without Relay compiler, or an older version of Relay compiler dependency. And right now, we don't do this by default and it requires opt-in via configuration to compile those operations, but it's actually not necessary if you don't want to use parameterized fragments. So the answer is, in CodeGen, we don't do it so far by default. But we want to allow people to do it in the future more easily. And also, to add on that, another thing that I did not speak about in my short presentation is, right now, if you compose everything into a single operation, then everything is as slow as all the data in the query is fetched and then sent to the server, to the client, sorry. But what we could do instead, which is also a pending feature in GraphQL, which is called a defer stream, is we can apply a defer directive on each of those fragments. And what that means is that the server does not wait until this data is fetched from the database or whatever before it's sent to the client. So what it will do is it will fetch all the data that is not deferred, send it to the client. So the client immediately has those data and can already render stuff. And then as the other data is then available and ready, this additional data will then be sent to the client until the client has all the data. So this also kind of solves the oh, I need to wait 5 seconds until this big query is loaded and sent to the client problem, kind of. Yeah, and this is also something we want to solve at some point, and yeah, share it with everyone because it's really cool.
Yeah, this particular thing has come up a few times. Like when we're, for example, like with Redwood, we do query resolvers. Like, sorry, services are the query resolvers, so we don't necessarily define each field. So sometimes within that query, you make an external service call. And if that takes a long time, the entire query fails, right?
Yes.
Whereas really, this is the perfect use case. And I imagine, especially if you use fragments, it allows you to render selectively as well, because it lets you select that part of the data. And if that part of the data is loading, you just render a loader.
Exactly.
Super cool.
So far, this is not really like widespread and also not really supported by the most popular GraphQL clients. I know Relay already supports it, but it's a special case. For Oracle and Apollo, I don't think that there are actually any people using defer and stream in production, and also like on the GraphQL side, defer and stream is still pending for the specification. So there's a lot of stuff still happening, and things could change and stuff like that. But once it is really ready and usable, it will be like mind blowing for everyone. And I hope people then will also start using it.
Yeah, I remember looking at Relay 2 years ago when we were first working on Redwood, liking the concept of avoiding waterfall operations, like you're saying, where each subcomponent has to do its own fetching. Being able to roll all the GraphQL up into a single statement is appealing. What I didn't like was the complexity that it produced in having to really reason about each of your components and fragmentizing them, and then knowing all of these ridiculous names that you had to then use to refer to them. And now your GraphQL becomes really opaque and you don't really understand what's happening. And so I'm wondering, this is really cool that you're doing this. There might be ways that we can smooth over some of the hard or confusing parts that Relay uses and do them in a more Redwood way, but still get the advantages of rolling up the query into a single one, or maybe using some of the deference streaming stuff. That would be a really cool way to avoid waterfall, which I think is one of the weaknesses that Redwood has right now, is that you can get yourself into a kind of this bad waterfall methodology.
Yeah, here I would say it would be kind of interesting if to experiment whether it is possible to actually like automatically detect what kind of components could be deferred and stuff like that, and then apply this automatically as part of the Redwood build process or whatever. And then so for the user, he does not have to care about this complexity, and Redwood would do all the magic. Obviously, at some complexity level, users would probably want to opt out of this, but it's definitely something that would be very interesting to explore. In terms of, yeah, you will, if you're using Fragment for describing your data dependencies, you will have a harder time like writing your first components, and especially for new people, grasping the concept and making sense out of it. I totally agree that it's like, it might seem overkill, but in my experience, if you start with a smaller app and then it gets bigger and bigger, I always miss this kind of pattern if I'm not applying it from the beginning. But also you first have to make this experience of having chaos and not having a nice data flow before you actually kind of realize that it actually makes sense. So yeah, it's not only just giving something to people. Very important is also to educate people and at the right time give them the right information for what they're trying to tackle right now, and not give them all the information and then they're just overwhelmed with patterns and stuff to do.
Yeah,
Totally
I'm imagining like the Redwood tutorial with like, oh, and here you have to like fragmentize everything, and people are like, you know what, never mind, right? Like GraphQL is already almost too much for a lot of people, right? And then you're like, oh, and let's layer on top all of these relay concepts, and people are just like, nope. So I think, but having that as an advanced thing that you could do, where you're like, okay, you have a waterfall issue in these circumstances, here's how you solve that. You can use this. You can use this fragmentation strategy where components can declare their dependencies in this way, like Relay, right? Like, but you just take the parts of Relay that are good, that are useful for these patterns, and you make them possible while still allowing people to just write their GraphQL the normal way, and everything works. And now you can have either, and you can still onboard people in a reasonable way without freaking out.
Well, and we have
not a GraphQL.
Tom, we have these different events, right? Like you're going to hit a route, and that's a major event. And then there might be individual components that are going to load. And so I don't understand the nuances of how we could. It seems like there's maybe some advantages to defaulting to, using fragments when the route loads, right? Because let's send one request instead of, if you got 15 cells, 15. But then now a page has loaded. And now we don't need to send that request with everything. You have an individual component that needs to send a request. So I'm really interested in how we could achieve both of those at the same time, right? Really get the best of both worlds just by default. I don't know the downsides of that. And Lauren, I don't know if that's even conceivably possible, but that's the data loading world that I think would be most efficient from a request side, if I'm understanding correctly.
Probably. Like there's no easy solution to this. We would need to experiment with it, and also from the user side, like what is easy to use, what seems too over-engineered or too complicated. Like it's always kind of like finding balance there, as you mentioned before. But in general, maybe we wouldn't actually need this like very granular component-based fragment parameterization at the beginning, but it could be like more simple that if you have different components on your top level route, you just declare fragments on the query type, and then by some magic, Redwood actually compiles this into a single operation for this single route. Maybe that could work as a first step. I don't know.
Lauren, thank you. Thanks for taking a shot at being one of our first presenters for these Redwood talks we want to keep doing monthly. And that was it. We just wanted to introduce some new ideas to the core team and then also the community. And thank you again for all the ongoing collaboration with the Guild. So feel free. So Jason from Replay is here. And Jason, you need to know that we just use the word relay several times. So if I say relay, I'm sure, I mean replay now, but we got a little bit of technology switch. So Jason, please jump on in and we'll hand over to you. And you're going to, I mentioned earlier, but I think one of the things you're going to talk about is how replay can be used with GitHub issues, which is of interest. And also give us an introduction to what replay is. Jason, are you there? I see your screen.
Awesome. Am I unmuted?
There you are.
Cool. Yeah, we've got Remix now, React, Replay, Relay. It's a real problem.
Got it. Well, and please introduce yourself to the core team. I don't think many people, I think you met Tom, but I don't know if you met anyone else.
I met Dom, let's see, 2 weeks ago. He helped me start getting started with the playwright test, which was pretty cool. Yeah. So I was tech lead for the Firefox debugger for a couple of years. We spun Replay out of Mozilla. It'd been a project there for about 5 or so years. Time travel debugging is nothing new for Mozilla. Mozilla had been working on a time travel debugger for C++ for 10 plus years. It was like a secret weapon in the fight against Chrome. One of us or 10 of them, but we had a time travel debugger. So without talking too much about what Replay is, I thought I'd just share a demo of a Replay I was just looking at with the Shopify team. They rolled out Hydrogen, which is built on top of React and Next. God, it must have been like early June. So that was a huge sprint for them. This is an app that they have on their demo page that runs on top of StackBlitz. And we just used Replay to make the recording. I'm going to take this URL and post in chat too if anyone wants to play with it as well. So you can think of Replay as something that you can record like a video. So if a user has any issue, they can capture it with Replay, put the URL in the GitHub issue, describe what they're seeing, and then you can go and view it. So in this case, the funny thing for me is this shop pay button takes like half a second, 2 seconds to load. So I can go in here, drop a comment and say like, hey, when does the shop pay button load? And then others can go in and look and figure it out. So if Replay were just a video recorder like Loom, we'd be done. But the interesting thing as a time travel debugger is we can do all the development, all the debugging after the fact. So when I go to DevTools over here, you want to go to DevTools too, you can jump in, go to the Elements panel, inspect anything on the page, find that shop pay button. I haven't really prepped this demo because I was just looking at this with Shopify and we did not look into this button, but I was like, oh, that's kind of weird right now. So let's see. Okay, first thing I'm seeing is the Shop Pay button is a legit web component, probably because they brought a bunch of Google people over to Shopify. So they're like the only people running with web components. It's like, that's interesting. You can also go to the React Components panel. Brian Vaughn, who'd worked on React DevTools for a while, joined Replay to build the next version of React DevTools because we can do shit that's impossible without a time travel debugger, make React debugging easier. So we can see that there's a component here, there are variant IDs, that's kind of cool. There's some hooks here as well. We can look at the network monitor, it's all here. The fun thing I was looking at with them is this add to cart button, which I think is this guy right here, right above Shop Pay. And with Replay, the craziest thing we can do is go in here and click on this plus button. And we click on this plus button, it's like going to VS Code, editing the code, typing console.log, going back to Chrome, refreshing, rerun doing exactly the same things, and then you can view that console log. So when I click here, the console opens. Got all these new logs right here. And then we can just copy and paste anything right into that expression, save, and then Replay goes to the browser in the cloud and tells it to run again. And it runs through the recording, stops at every one of these points, reevaluates the expression, and sends them back to the console. The cool thing about Replay is because we're a time travel debugger, we don't actually have to like make new API calls. We don't have to have the browser running on the exact same computer with the exact same session details. We have everything in the recording for the browser to run again. And it thinks it's 5 days ago. It thinks it's Thursday. It thinks it's on John's computer in Toronto running exactly in that environment because we can just replay exactly the same way. So when you add that print statement, you're guaranteed to see exactly the same logs you would have seen if John had that in his code the first time. Does that make sense? Cool. And then the really crazy shit is if one of these logs is really interesting, we can just rewind and we're there. So at this point, there was no Shop Pay button. If we jump down here, oh shit, there's still no Shop Pay button. Like this button really takes a while to come in. Like we're here and it comes in here. So I don't know how much time I want to spend on this, but let's see if there is a Shop Pay button component. Okay. Cool. The funny thing here is the last print statement here is still like a good half second before the Shop Pay button shows up. So there's something weird going on in this app where the Shop Pay button component takes a while to load, and I don't know what it is, but with Replay, we can begin figuring it out. Cool. So I started looking at, I don't want to spend too much time on Shopify and like Hydrogen. That's fine. I think it's way more interesting to see what you guys are doing. So I started looking at just like the very basic Hello World app. And of course, we can like inspect React components, see all that. For some weird reason, the splash page just like overlays everything. Maybe we can find like this element right here. It's all fine. The fun thing for me about Replay is I can actually begin looking at the Redwood internal code. So like, sure, you can go to routes and like see it rendered once, but like this app is really, really simple. It's way more interesting for me to jump in and see the router itself. So I started asking Dom some questions as well, but you know, we can go in here, see other routers instantiated with use auth and param types and all that stuff. But what I really like is all the functions below here, like isRoute. And if you're just reading the code, you have no idea what this stuff is. But if I can just go in here and update this function, I believe it's going to render here. And I can see that isRoute takes a node. And the crazy thing, if I remember correctly from like a week ago, is that this node is actually another React component. Is that right?
Yeah, I think so. Everything's just a React component in there,
Yeah.
and then
like all the way down. Actually, maybe it's not initially, but then down here becomes one. Is that it?
Yeah, so if you call the loader, it then becomes the React component.
Okay. So we're going through here, through the render, into location aware router, and then into has home router right here. There's your child, and then into is route. And then we have this check to see, is it a React element? If so, what's its type? Is it of type route? That's pretty cool. So with product teams, the best thing is if support or QA can record a replay and give it to you, and then you got your Jira ticket with the replay. With open source projects, what we've been doing is providing docs so you can update your issue template and then just point to a step-by-step guide to like download the replay browser, make replays, so replays can be added to any issue. And then the other thing we've been doing recently is creating a whole new dashboard for test suites. So we can record playwright tests, Cypress tests. We just started looking at this last night. I mean, I talked to Dom about 2 weeks ago and then forgot about it, but we looked into it last night and we got the smoke tests running here. So it looks like 6 of them passed and 3 failed for some reason. So we can actually look at those too. But the really cool stuff here is we can go into that playwright. So I just started looking at the code here. There's components, authors, this app. If we jump all the way down here, it's going to show this blog. And we can go into the author component and just like console log author and see what's going on. Of course, like the really cool thing would be to go into the framework code and see what it's trying to do, because if it's going to regress, it's not going to regress because like the app is different. It's going to regress because you made some change to the library and maybe the router is slightly different, and we could debug that as well. So that was kind of a whirlwind tour through all the functionality and 2 different use cases: issue templates, say, bug reports, and test suites. I'd love to hear what you think, and yeah, any questions you might have.
This last thing is like crazy cool because anytime one of these smoke tests fails, especially in the testing for Storybook, like one of these playwright tests, like we're not sure if it's a timeout, if it's a real bug, and setting it up locally, it takes like just a couple minutes too long. And sometimes you don't even see it locally for whatever reason. So just to get the exact same thing like on the GitHub runner is like amazing. Yeah.
Yeah, I didn't show it here, but you'd get a comment right next to like the Vercel preview branch kind of comment with links to the replays.
So is that in integration with Playwright, or is that in integration with GitHub? Where
Both.
Like both. Okay.
Yeah. So we've got a replay playwright adapter that teaches Playwright to open our browser. Yep.
Yeah. Okay, that makes sense. That's why I was like, how is this yeah, that makes sense now.
It's really nice when you're the browser because everything just goes right through. By the way, like we have the React tab, but it'd be pretty easy to add new tabs as well for just anything we can pull in.
It's gonna say
Jason,
this
this
makes
is-
me.
Go ahead, Dom.
Oh, it makes me want to stop using Babel to compile the disk because it just looks so much uglier when you're debugging the internal code. But
Yeah, or we're just fixed source maps. So replay will work with source maps, so you can add a print statement in the original code, and then we we use Babel as well to reverse engineer the expression that we're running that like minified thing.
when Full Story first came out, feels like a long time ago. They had free plans, and they didn't cost like one developer per year to run.
Yeah.
It was such a powerful tool to do this. And so I was using it on my application. I never imagined, and it was phenomenal there. I mean, it really,
Yeah.
we could resolve bugs that users didn't even know they were having. When I never thought about using it on the support side. So that's really fascinating. Maybe walk me through a little bit more. So a lot of startups using Redwood.
Yeah.
A startup runs into a bug, right? So
Sure.
some edge case they discovered because they're pushing features hard, and they want to report that back to us and give us. Now, if they record inside their app, then in a way they'd be showing us their source code for their app, maybe, I guess. But if it's just the client side, then it's anything client would be seeing. So maybe there's a way of like, now they can share code with us without feeling like they're opening up everything.
Yeah.
Would it be that, or is how you're typically using this? We have our test project, and that's where people will be replicating and recording.
No.
Curious how that might work.
What we can do is set up a Redwood team for you. Actually, a Redwood team for smoke tests, keep that separate, and then a Redwood team for support. And startup starts using Redwood. They find an issue in the auth hook, and they want to get that fixed. So they come to you, they file an issue. You look at it and you're like, yeah, I don't really know exactly what's happening here because auth's really, really complicated. There are a lot of ways it can fail. Fine. They can record the replay, share the replay with you privately. You can add it to the replay team. Sorry, the Redwood team. And then anyone on the core team could look at it. And they can see what's going on, but it's not going to be a public replay. It's not going to be open for the world to see.
Got it.
Yeah, so there are a lot of parallels to Full Story. I don't think you could ship Full Story with the framework. That would violate a lot of open source ethics.
Understood.
But even if you did, what we hear from people is just seeing the Full Story video doesn't give you enough context to understand why auth might fail, or at the framework level, how routing is working. You can see that there's a problem. Maybe you could see there's a network request that was fired that shouldn't have fired, but you can't go in and actually debug the code. And the difference between a session replay tool like Full Story and a time travel tool like Replay is with time travel, we're actually replaying the runtime again. We're not just like capturing the video ahead of time.
Yeah, we used Full Story quite a bit at Chatterbug, and it was amazing because the video stuff was always problematic. And it was nice when we accidentally left a bunch of console outputs in the code, because that was the only way that then we could see what was going on. So we would have some debug output, and that would then we could see in Full Story. But then, you get to a certain point and you're like, I need to know more. Like, I can't, like, this is insufficient to go further. And those are the instances where being able to just have a user send them to just be like, well, just load this with Replay and record it for me and send it to me. Like, it eliminates the doesn't work on my machine issue. Like, there's so many different machine profiles. And when you get into things like video, then there's like a million billion things that can go wrong and you have no idea. And like this is,
it just becomes a habit.
I love it. Like, being able to do this at all in the universe, it would makes the issue, filing of an issue, for a person to say, I had an issue, here it is, and it contains everything that we as developers need to diagnose the problem, is like.
And by the way, the fact that you're working with startups, Replay is a startup's best friend because they're moving fast. By definition, they have very few engineers who are trying to stand up the entire product. So they're strapped for time and things are constantly breaking. So some of our best customers are the one who found product market fit really, really early. And now they're trying to scale the product, scale the team. And when they put replay into their workflow, all of a sudden new engineers who wouldn't have enough context can figure it out as well. So what's really exciting here is that we can help you with your issue queue. You know, the 30 issues that are open that, you know, you have the context, but they're still hard to understand. Like, okay, I have a repro, but what the hell's going on? Great. But then we can also teach all of your users how to use replay for themselves on their team. So in the last 5 minutes, who would like to get set up? Cool. So it's really not that hard. First of all, what I'm going to do is just post this link in here of the useauth test run. So if you want to share your screen, you can jump in and you can view that replay too.
Cool. I wasn't, did you want me to share my screen? I didn't.
Yeah. Could you share your screen?
Yeah. Okay. I'll have to share a portion of the screen. There we go.
Oh, perfect. Cool. So if you want to add your first print statement, you can go on to line 9 and click that plus button.
Line 9 plus button. Sure.
Yep. And you'll see the console just like lit up with all those logs.
Yeah.
Yeah. And let's edit that to add author as well.
Okay.
Awesome. And if you hit save, we're going to run through the recording really quickly, reevaluate the expression, and there it is. And then you can just fast forward and rewind. Awesome. So you've got it. The only other thing you need to, yeah.
This is where the test is failing, but
why?
It's probably just a timeout or something, because it looks like everything is working in the end.
Oh no.
But
That's hilarious.
yeah.
I kind of want to know what it's asserting for and then see that request that failed. Okay, I'm not going to get distracted because we only have 5 minutes.
Sorry. Yeah.
If you go to replay.io, you can click download and then you'll have the browser.
Yeah. I just had it open.
Oh, cool.
But it's fine. But in order to record the replay, I have to use the browser.
Yes. So think of it like a recorder. Just like you have to download the Loom recorder and other, like you have to even download Loom. The reason is we don't record the DOM on the page or JavaScript calls. We record the browser itself. So replay works by capturing the 400 or so Mac OS calls like open file, read file, make directory, all the socket stuff. And then when we replay, the browser thinks it's talking to the original OS, the original computer, but of course it's just reading from the recording. Okay, cool. So now that you're in here, you can click the sign in button in the top right. I'm just going to take some shortcuts. That should bring you back to Firefox, I hope. Cool. And then you can continue with Google. We either do Google SSO or we default to the enterprise SSO. So like whatever you've got, but Google's our friend. This is another thing, right? Like as a startup, we do not understand auth, so we just did the simplest possible thing. And now we probably can go to any page you want to go to. Like, you know, if you got a good Redwood app, we can go there.
Okay. What did we break recently?
Yes. Oh, by the way, just because you clicked that button, that brought us to our little demo flow. So we're now recording the app. So you can just click stop on the top right, and I'll stop recording that little demo app. But yeah, let's find an example where something broke.
You're putting me on the spot. I haven't deployed anything in a while. Yeah, I've been deep in the build tool world for a little while, so
okay.
Nothing I can capture with replay at the moment. But you just tell me what to do. We can do it on the demo page, maybe.
Oh yeah, sure.
Yeah.
So if you click record in the top right,
Mhm.
the game here is to get 3 of a kind. So you click the circles until you get 3 of a kind.
Sure.
You know, just classic time travel. Awesome.
Okay.
Now you can click stop.
Mhm.
This is the classic flow. When you open this up, you can edit a title, change privacy, all that. So you, right now, by default, it's only for you.
Okay. Cool.
Yep.
Save.
Yep. The video is going to work exactly the way you think, but the fun stuff is on the DevTool side. And you've got the console on the right. So if we click on any of those messages, that's going to take us to the JavaScript that ran.
Sorry, you guys are hitting here.
Yeah.
Okay. Cool. So yeah, so I can see everything that's happening at
Yep.
each time.
And you can fast forward to any of those console logs.
Mhm.
And we tried not to be opinionated. So we basically wrote this with jQuery.
Okay. Uh-oh. Trigger word there.
Oh, jQuery is great. Mutuals is
Uh,
great too. They're all great.
Okay. Okay.
So if you
and,
fast forward to one of those console logs,
to one of these here.
yep,
Okay.
that drops right in the code. And then we can see how the app works under the hood. What's actually happening when you, for instance, click on one of those circles.
Okay. Cool. And I can just log anything I want.
Yeah. It's all there.
Super cool. Okay. Nice.
Wow.
All right.
You know, Danny, I was immediately thinking, right, we could pull for a PR, we have the Git pod URLs, right? And so that might be another way right now we could start using this. I wonder if they could sync those two up a little bit better.
Yeah, I think even with just the smoke test, it's going to save us a ton of time.
Yeah.
Because like Dom said, it's just when you have like 5 PRs to get merged and one of the smoke tests are failing, you don't want to spend 10
totally.
minutes running it locally.
No.
Whereas you just want to go and quickly see what's happening. And if it's just a timeout or something, fine, you know, bypass it. I think that's the sort of thing for us, especially, it's going to make a big difference.
And,
Well,
and
we've
Jason
got
said,
that PR that's getting close.
oh, nice.
Yeah.
And Jason already said that we're his favorite open source project. Actually, the whole replay team just loves Redwood. So we get it for free for as long as we want or something. I don't know. It was something like that, right,
Let's
Jason?
put it this way. If you get us a lot of startups playing with replay, you are our favorite open source team.
Yeah, that's what we like to hear. Well, if they're not using, again, yeah, just the concept of session replay. I think that's what I wanted to, with Full Story. I mean,
Yeah.
blew my mind, opened things up. So to make that more accessible, it can't help but help with dev iteration time. Like it was phenomenal. So yeah, I think this was it. I wanted to make the intro.
Yeah.
Okay, everyone, meet Jason. Jason, meet everyone.
Easy.
Take it from here.
Dom will be in touch.
Well done. Yeah, it's a
Thank you.
phenomenal thing. So, all right. Any more questions? We're at the end of the hour. Lauren, I think you're still there. Thank you so much. Jason, thank you. We did YouTube, and we wanted to do this monthly. This is an experiment we just started. This is the second time, and just share these also with the community around Redwood. It'll be on YouTube, and you've got a great demo now that you could share as well, Jason. So thank you all. Any final questions?
I just saw the Redwood joke, which I like.
That was DT.
Well done.
All right. I'll stop the recording. Anything else before we end? Well done. All right.